Okay, and here's the last, and I would say definitely the most important way of communicating concentration. And this is called moles per liter. Now, I mean, I will be honest, moles per liter kind of spells out exactly what you need to do. So the concentration is quite literally the number of moles of solute divided by the liters of solution. So this one is the only one that incorporates the unit moles. This is why you don't see moles per liter on consumer goods. Like if you go to the store and you buy a container of vinegar. Vinegar is acetic acid dissolved in water. So it's a liquid solute in with a liquid solvent. And it's usually around, I think, 9%, give or take. Notice I said percent. When you buy stuff at the store, you're going to get percentage weight for volume, or sometimes percentage volume for volume. They don't give you moles per liter of acetic acid because most people don't know how to calculate that and they don't understand what it means. But since you guys are in Chem 20, yeah, we're going to need to figure out what it means. We're going to start really simple. I'm just going to spoon feed you a moles value, and I'm going to spoon feed you a liters value. So what if we say something like 2.5 moles of salt dissolved in, I don't know, let's say 12 liters of water. So the formula is very straightforward in this case. We have moles of solution, or sorry, moles of solute. That is usually called N. If you remember, moles is usually determined or shown as N in a formula. And in this case, our volume is in liters, so N over V. So all I need to do is go C equals moles of solute, which is 2.5 mole, divided by liters of solution, 12 liters. And again, we do our math. So 2.5 divided by 12 gives me 0.21. And it's important here that we obey laws of units. So nothing canceled out here. All I did is I took the moles number and I divided by the liters number, and that's it. So since nothing canceled out, I still have the unit moles up top, and I have the liters unit on the bottom. So this is literally moles per liter. What happens if you're given a milliliters value? So what if I say 1.7 moles of, who knows, let's go calcium chloride. Dissolved in, let's go milliliters, let's go 650 milliliters. Okay, so same idea. We need to turn 650 milliliters into liters. So I'm going to do that first. So 650 mils. And I really like doing the conversion this way. And I know some of you don't. I know some of you are diehards and you're going to be like, hey, do we just multiply by 1,000 or do we divide? Every single year in Chem 20 that I've taught, there's always kids who are like, do I multiply or do I divide? If you just follow this kind of unit conversion, you don't ever have to wonder. I do know that there are 1,000 milliliters in 1 liter, and your data book even tells you that. But if I write it like this, I can be sure that I'm going to do the right thing. So 1 liter goes on top because I'm trying to bring in the unit called liter, and milliliters goes on the bottom, and there are 1,000 mils in 1 liter. You see what we're doing here? Milliliters can be removed, and liters is the correct measurement of volume for this. So we get 0.650 liters. Beautiful. We have a moles number. We have a liters number. All we need to do is go C equals moles value, 1.7 mole, and I guess I will say CaCl2. It's always good to be descriptive and write down all your units. I noticed I didn't do that on the previous question. And then divided by 0.650 liters. And that's going to give us a moles per liter value. And that gives me 2.6 moles per liter. Of the chemical calcium chloride, aqueous. But what if we have to get into masses? Like, what if I give you a number of grams of something and I ask for a moles per liter concentration? Not hard. Not difficult. All we need to do is take this formula that we are learning right now. Remember, you get your amount of chemical into moles, you get your amount of solution to liters, divide your mole number by your liters number, and your units at the end of the day are going to be moles per liter. So let's do a very simple one using my favorite chemical. It's not actually my favorite, but I really like it for chemistry because it's got a nice, easy molar mass that I've got like memorized. So let's say we measure out 16.5 grams of my favorite, sodium hydroxide. And let's mix that sodium hydroxide into 4.56 liters of water. So we have to turn our grams value into a moles value because we're not looking for grams per liter right now, we're looking for moles per liter. So I need to turn grams into moles. So that's the first thing I'm going to do. So we have 16.5 grams. And I'm going to draw a little conversion bracket, and I know that my answer should be in moles. This is not the full question, remember, we're just getting grams into moles, then we'll divide the moles value by the liters value. So I'm going to take NaOH. Remember, to find the molar mass, you add up all of the atoms that are present, and the beautiful thing about the molar mass of sodium hydroxide is it is 40.00 grams per mole. It's a nice even number, really easy to memorize. Again, that's why it's kind of my fave, because you don't have to do all the adding and calculating the molar mass. So now we need to decide how are we going to put this into the actual equation. Very simple. If we want moles in our answer, we have to put moles on top. If we want to get rid of grams, and we for sure do because I don't see grams in the answer, we need to put 40.00 grams on the bottom. So we get this cool ability where we can wipe out the unit of grams, and we can verify that our only remaining unit is moles. So now it's just a matter of dividing. So 16.5 grams, oops, divided by 40 grams per mole gives me, I'm going to type it in this time, 0.4125 moles. And if you end up with a number that has way more decimals in this step, remember, the only time you ever round a number is at the very end. So I know that we have 3 sig digs from here, and we have 3 sig digs from here, and you're like, well, why isn't it 0.413? Because we're not done the question yet. So now I have a moles number and I have a liters number. So we're ready to roll. So I'm going to put my moles number up top. And I'm going to put my liters number on the bottom. So divide what I had by 4.56. And we get, let's see, we get this value here, and we're going to turn this into a scientific notation. Oops, not enough space. Let's stretch that out. There we go. Ah. There. So it is 0.09046, and our unit, because nothing has canceled out, is moles per liter. Always a vertical fraction, never a little slash. The slashes are bad. Nobody likes them. If you like them, you're wrong. You should not like them. So we only have 3 sig digs to spend. So there's my first significant digit. So I have 3 digits to spend. So I have 1, 2, 3. Since this is the third sig dig, it's affected by what's after it. So my value is going to be 9 decimal 0 5. Now it's going to be times 10 to the power of something. Remember how we solve this. I'm going to put the decimal here because that's where it is in my answer. And I'm moving the decimal 1, 2. 2 to the left, which means that it's 9.05 times 10 to the minus 2 moles per liter. So it's as simple as that. Let's do one more where we actually have to add up and calculate the molar mass of a substance. So let's say we're in the lab. I really wish we could have done a lab. I'm a little bit sad about that. Let's say I say to go measure out 36.7 grams of potassium nitrate mixed into 1.77 liters of water. So this should be trivial. We need to turn our grams number, whoops, into a moles number. How do we accomplish that? We got to find the molar mass of potassium nitrate. So the first thing we need to do, and this is something that is requisite from, Science 10 and the starting part of Chem 20, we need to be able to turn this name into a chemical formula. So it's an ionic compound for sure. So a potassium ion is K+, a nitrate ion is NO3 minus. That means that the formula of this chemical is KNO3. So that means we need to add up the mass of 1K, 1N, and 3 O's. So I'll say 1 times, what's a K? 39.1 grams. 39.10 grams per mole. Plus a nitrogen, 1 times 14.01 grams per mole. And then 3 times oxygen, which is 16.00 grams per mole. So I have to add those up. It's going to take me a sec. 39.1 plus 14.01 plus 48 is 101.11. So the molar mass of this chemical is 101.11 grams per mole. So going from chemical name to okay, what ions are in it, going from okay, what ions are in it to the formula is how we find out what's in it, and that tells us how much the molecule or the chemical weighs. Now we need to turn our grams number into moles using the molar mass. So we do it the same way, 36.7 grams, conversion bracket. We know that our intermediate answer needs to be in moles, and so in order to cancel out grams, 101.11 grams goes on the bottom, and the unit moles goes on top. And grams on top and grams on the bottom cancel out. We verify that the only unit left standing is moles, and it is, so we're killing it. We're doing great. So 36.7 grams divided by 101.11 grams gives me a long number, and yes, I'm going to write the whole thing here, or I'll do most of it. And remember, I'm not going to round this because I am not done the question. Only round when you're done. So now we got a moles value and we got a liters value from before. So we take the moles value, we divide by the liters value. Piece of cake. And I'm going to type out that moles value just because it's kind of big and unwieldy. 710.217. You don't need to do this when you're writing a question, but it does. If you were to handwrite this during an exam, which you're not going to have, it would take up a lot of your time. It's better to just put like 0.3629 ... but leave the whole entire decimal value in your calculator. And then we have 1.77 liters. So I'll divide that, 0.77 liters, and we get 0.205. So 0.205, and that's in moles per liter. And we don't save any space or time by writing this guy in scientific notation, so we're not going to do that. So remember the steps. Get your chemical amount into moles. If it's already given to you in moles, you're great. You don't have to do any work on the top. Then get your amount of solution into liters. If it's in milliliters, you must convert it to liters. If it's in like megaliters, you gotta convert it to liters. No matter what, liters is your denominator. So you gotta make sure your value is in the unit called liters. And then you just simply take the moles value and divide by the liters value and make sure that you write down the units, moles per liter. And I'm also, just because I want to be very complete, I'm going to also say KNO3 bracket AQ to make sure that the person knows what chemical I'm talking about. And I should also do that here. NaOH bracket AQ. All right, that's it for this video. More to come.